Hello, class. This is the first video lesson for the semester. We're going to cover activity 1.1. The material that you see cannot be found in your textbook. However, I've included a PDF of this material in Canvas. So if you'd like to print out the activity 1.1 handout, I think that would be helpful because I'm simply going to read through the document and we can mark the document up together to provide a good set of notes. So in this class, we're going to do quite a bit of graphing, and we're going to see what information we can extract from graphs. As you see in the title, graphs often tell a story, and that is very true. So the two graphs we're going to look at will be quantitative and qualitative graphs. So we'll start with the qualitative graphs. All right? I want you to realize that the qualitative graphs, you won't see any numerical information on the graphs, right? You don't see any numbers where it says total distance, right? There are no numbers here, or where it says time in minutes. You don't see any numbers there, right? So it's just a qualitative graph. And I look at this example, it says Marty jogs around the track every other day. He usually runs at a constant rate of speed. This phrase constant rate is very important. It means we're going to have a straight line, all right? So whenever you see a constant rate of speed or a constant rate of pay, we're going to have a straight line or a linear line. So in this situation, the distance Marty runs depends on the amount of time he runs, right? And you think about that, that makes sense, right? The longer you run, the greater the distance, right? So the distance you run depends on the amount of time you've been running. Okay, so it says time will be on the horizontal axis, that's time, and distance will be on the vertical axis, right? And again, as time gets larger, well, the total distance run becomes larger, right? So we can observe that our graph rises from left to right, right? So the graph is increasing. As I scroll down a little bit, you'll notice that there's mention of input and output. Right, so here's input and output. So the time is considered the input and the total distance is considered the output. So I've tried to label the input and the output on the X and Y axis, or the horizontal and vertical axis. And I want you to know that the input will always be on your horizontal axis, and the output can always be found on your vertical axis, okay? Right, and then they give us a nice question for ourselves. Ask yourself, as input increases, what does the output do? Right, in this case, as the time in minutes were to increase, what happens to your total distance? Well, as the time increases, your total distance will increase. So let's take a look at part 1, example 1. So for this example, there's really no work for us to complete. They actually give us the answers. If you look at segment A here, right, we notice we have time in minutes and total distance in miles as my horizontal and vertical axis. So my first 5 minutes, it looks like I run a half of a mile. Right, so again, just from 0 to 5 minutes, right after 5 minutes, I've run a total of 0.5 miles. But then you notice the next 5 minutes, it looks like I run 2 miles, right? I go from a half a mile to 2.5 miles. So that means my speed must have been increased, right? If I run a half a mile in 5 minutes, and then another 5 minutes, or the next 5 minutes, I'm able to cover 2 miles, that means I must be traveling at a faster rate, okay? And I think that's what they indicate in this blurb over here, right? The first part of the graph is labeled A. It's flat compared to the second part labeled B. So I guess what we're really trying to say is the steeper the curve, the greater the rate. In this case, we're talking about the rate of speed, right? So at segment A, it's less steep than segment B. So I think my rate of speed at segment B is going to be greater than my rate of speed at segment A, okay? So really the key takeaway here is, listen, the steeper the curve, the greater the rate. In this case, it's rate of speed, but we could be talking about a pay rate. Maybe you earn $6 an hour, you get promoted, now you make $10 an hour. So once you get that promotion, the line would be steeper. All right. So let's look at problem 1 and 2. Right. This is where you have work to do. So I want you to look at problem 1A and determine where should you put a line. I want you to draw a second line on this chart. Do you draw your line above or below? And then do the same thing for problem B. So we're asked to draw a line that represents a faster running speed. So we know the greater the rate, the steeper the line. So any line that's steeper than the original line will work. And then for section B, or part B, it says a slower running speed. So we need a line that's less steep. So, and again, pretend these are a straight line. I'm drawing on a monitor with a stylus, so my handwriting is atrocious, but hopefully you'll use a straight edge to draw straight lines. Okay, so faster running speed, steeper line, slower running speed, less steep. Okay, part C, finish telling the story. Now, I like these types of problems for quizzes and tests. I'll draw a graph. And remember, at the beginning of this chapter, we said graphs tell a story. So if the vertical axis is total distance and the horizontal axis is time in minutes, it says Marty begins to run at a relatively, I guess this line's not so steep, so I'm going to say slow pace. Then after a few minutes changes to a, looks like this line's steeper, so I'm going to say faster pace. And then a few minutes later, Marty, well, see this, my total distance is not increasing or decreasing. This is a horizontal line. So as time goes by, his distance is not increasing or decreasing. So that must mean he stops. Okay, so I think this makes sense. Let's look at part D. Part D says, explain why the graph below has no meaning. And then hint, note how the axes are labeled. So it looks like as time goes by, the total distance is decreasing. Well, think about it. Really, total distance can never decrease. Let's say you are, we have a person that's standing, and they walk 10 feet forward, 20 feet backwards. So here's my little stick figure. And again, I apologize. I am no artist. I'm pretty good at math, drawing and writing, not so much. So imagine I walk 10 feet to the right, then 20 feet to the left. Did I go negative 10 feet? Would my total distance decrease? No, your total distance would be the 10 feet plus 20 feet, right? So I've walked a total of 30 feet. My net distance might be negative 10 feet. My position to where I started would be 10 feet, but my total distance traveled would be the 10 feet I walked forward plus the 20 feet I walked backwards. All right, so again, I would have walked a total of 30 feet. So your total distance can never go down. It could stop, right? If I stop walking, my total distance won't go up, it won't go down, or it will increase every time I take another step. It doesn't matter which direction, my total distance will increase. Right? Now notice this big hint. We're going to come up with another problem in the next video or so where this value is allowed to decrease. It won't be total distance. All right, so just remember this problem. If it says total distance, well, your distance can never decrease.